Hello, my name is Pete Smith. I'm a professor in allergy in Queensland, Australia. Thank you very much, Susan, for the invitation. And I'd like to talk to you today about advanced glycation end products, or AGEs as we call them. We see them when our body is damaged, but I'd like to speak about how we can see them in foods and how we can create them in our bodies, but also by the ways in which they're created in the way that food is prepared.
We certainly know that food allergy is increasing, as is eczema, and we have many hypotheses that contribute to this. Severe food allergy has increased, and this is not overdiagnosis. We see this in the UK, the US, Canada, many developed countries, and it is more common in urban areas than in regional areas. In Australia, in green here, we see rates of eczema in young children. Similar surveys, we also see increasing rates of food allergy as well. We really do need to rethink what is causing food allergy. Hygiene, which has been one of the major propositions, has not dramatically increased over the last 25 years, where you have seen a 700% increase in food allergy in young children in Australia. Vitamin D, that we know is also important, cannot have changed that much in a generation. And our genes may have changed somewhat with our environment, but we can't explain it all. Most research looks at the way our immune system adapts and behaves, our adaptive immune response and IgE antibodies. And I'm trying to focus at the detection of threat and why that may be misread. When we're being injured, it releases products called alarmins, of which the most important is the high molecular group BOX1. When a cell dies, it normally withdraws from immune activation. No alarm is raised as the nucleus absorbs, becomes dense, and takes in cellular contents, and the cell is simply just replaced. Injured though, it tells bystander cells there's danger going on. It releases an alarm. It also engages our immune system to recognize what is about, which may include foods, and then react in a more professional way, in an amplified manner, if they see that threat again. So we know that when this occurs, high molecular group BOX1 is released along with S100 proteins. These activate dendritic cells and they mature and will take signal from that area. They will activate nearby cells to get on the defense and make proteolytic enzymes. And these dendritic cells will take messages along with a HMGB1 to tell dendritic cells and other immune cells something's going on. They will bind to a receptor called the receptor for advanced glycation end products, or RAGE receptor. But this receptor is also promiscuous, and in binding to high molecular group BOX1 and S100 proteins of an alarm response, they also bind to advanced glycation end products that we can make in our body, but we can also have in our diet. Advanced glycation end products are very capable of causing dendritic cell, our immune detecting cells, and activating them, and they will also then secrete HMGB1 to say something serious is going on. I've talked about HMGB1 activating dendritic cells, and these dendritic cells talk to T cells, which can direct somebody towards an allergic response if an allergen may be present. Advanced glycation end products are the formation of protein plus sugars, and they will form in our body, but we get the vast majority in the food that we eat. If food contains a lot of sugars and a lot of protein, and they're heated up together at high temperatures, as you get with frying or microwaving, we get formation of advanced glycation end products. There are lipo-oxidation products from lipids and fats plus sugars, but the main thing is having sugars present. So the glycation hypothesis is the Western lifestyle promotes allergic disease. We published this in JACI, the Journal of Allergy and Clinical Immunology, in 2017, and it is open access, and that's probably the easiest way to get a lot of this data. So glycation is a sugar and a lipid, and normally this can be deposited in our tissue, and some of them are excreted. And part of that is the Maillard reaction, which we can think of tissue becoming brown. The evidence that we have supporting the hypothesis of linking glycation and increasing glycation end products in our diet is about society change, maternal diet and pregnancy, pro-glycation states such as diabetes, as well as animal studies on anti-glycation therapies that I won't have time to discuss with this brief overview. With Western diet, this famous slide by Bark showed that with a reduction in infectious diseases, we're seeing both autoimmune diseases, type 1 diseases, and allergic diseases, type 2, such as asthma. We certainly need to be more sensible about the way that we eat. If we look at Bach's slides, we can see sugar could very well match that pattern. And there's very good molecular mechanisms that could explain that. They can simply affect our microbiome, but they also increase glycation. Corn sugars in particular fast tracks to methylglycol, which create glycation. And upsizing certainly didn't help. We certainly could correlate this with our fast food outlets in Australia, and I guess also in the US. In the US, young children have French fries, one of the most common foods eaten by infants and toddlers, even up to 5 years of age. As children get older, they eat more and more sweets. 200 years ago, we used to have less than 5 grams of sugar a day. Now we have more than 100. Most of that sugar 200 years ago used to go into making rum. And rural areas certainly have less of that, and they have less allergy. Sugar consumption increases in later childhood. Urban children have more fried foods and obesity as well. Mediterranean diet, we cook food slow, put in herbs, there's less glycation. And food processing, heating foods up, microwaving increase the formation of advanced glycation end products. Bacon is particularly high in this. It's not all bad. We can eat sensibly. We avoid overeating, avoid sweetened drinks, marinate and low-cooked meat, avoid bacon and grilled cheese, consume garlic, cinnamon, polyphenols in fresh plants, and avoid obesity and exercise regularly.
So while it might be concerning that we have advanced glycation end products increasing in our diet, there are many ways of reducing it. We can eat healthily, we can cook our meats at low temperature, use herbs, we can exercise. We can avoid cigarette smoke. We can avoid rich sources of fructose in our diet. And we've got a lot to look forward to as we discover new ways to improve our health. Wish you all the best for the rest of the meeting. Bye.